The last team for remote coming up. The title alone, I think, captures something about this team's spirit, and because they have a wonderful team spirit. It's called Hangry, and it's to help you figure out how to reduce the amount of decisions you have to make just to get to eating. Just, I want to eat now. So I'll let them tell you all about it.
Thanks, Omri. Hi, I'm Adil Minocherhomjee, and my teammates are John Riccardi and Morgan Brown. We're here today to introduce Hangry, an opinionated dining app. How often have you been hungry but unable to make a decision on what to do, which makes you angry? I find myself flipping through Uber Eats, Yelp, or Foursquare for 30 minutes every time since there are just so many options. But what if you could avoid all of this frustration based on your preset preferences just one time and didn't need to think about the decision-making process ever again? Meet Hangry, an iOS application that makes your decision-making process a one-time thing. Hangry works by asking the user two main questions about price, rating, distance, and cuisine type only one time up front. First, we ask the user which preferences they care about the most. Then, we let the user select their preferences. On an existing platform like Yelp or Google Places, every time I want to find somewhere to eat, I'd have to run 4 different sorts manually and try to remember the ones that I consistently see at the top of the list. However, on the Hangry platform, just set your preferences once and then get back the results based on your sorting, weighing quickly every time after that. This is really useful for people that are always traveling or that are indecisive, since they kind of know what they're looking for already and don't want to waste time to do multiple different searches when trying to figure out what to eat. There are only 2 more steps in the workflow. Choose your preferences and get your top results one by one. No paradox of choice. So we use Facebook's React Native to build the iOS app, open source Expo to compile the iOS app, Foursquare's Venue API to get the underlying data, and Google's Firebase to store the user preferences and execute cloud functions. Now I'd like to transition to John to get into the data flow details.
Thanks, Adil. The idea behind our app required several platforms to work together to produce good recommendations for the end user. So we had to spend a lot of time thinking about how data would flow through our app. Let's walk through it. First, the user logs in and sets preferences. These preferences then saved to Firebase's real-time database. If they're already saved, they're sent from the database back to the phone when the app loads. Next, React Native sends a request along with the user's preferences to the Firebase Cloud function. Our Firebase Cloud function takes the user's preferences and sends the request to Foursquare's API to get a set of restaurants in the user's area that match their location, cuisine type, and preferred distance. Once we have a basic list of restaurants, we rank them using an algorithm and send them back to the front end. Morgan will talk more about how we rank them a bit later. On the phone, React Native receives the restaurants and renders them on the user screen with the top option up front. Giving the user tailored choices means they'll have to do less digging to find a good option. Users can then look through the top menu items or swipe to see the next best choices for restaurants if needed. When they find a restaurant that they like, they can navigate to that restaurant using Google Maps. The next time we want to use our app, no setup is required, and opening the app will automatically give you a customized ranked list of restaurants in your area. Now, Morgan will give you some more detail on how we rank our restaurants for the user.
Thanks, John. The flow of our rating system looks a little something like this. Our first call to Foursquare is to retrieve all the restaurants within your preferred distance that match your preferred categories. Before Foursquare's second call is made, we weed out restaurants that don't have menus. Once that is done, we can make our second Foursquare call to retrieve restaurants' menus and the ratings. After the response comes back, we can finally rate our restaurants. To rate our restaurants, we use the user preferences and the restaurant's details to fill a weighted mean formula. The outcome of running this formula is the aggregate score for each of our restaurants that we can send back to the user, sorted highest to lowest for viewing. All of this only takes a few seconds, and in comparison to finding a restaurant on Yelp, is much more efficient and way less painful. Overall, we had a great time developing this app since it solves a problem we have all ran into. If you'd like to check it out, you can check it out on our GitHub repo. Thank you.
I think I'd remember, if you liked Hangry, go ahead and like the post, like the pinned comment, and get out the votes for them. So I was impressed. They did a great job. Oh, by the way, hi, Jess. They did such a great job of presenting an incredibly clean, simple user interface. They really made it easy for the user. And by offloading all of the hard work on their end, I was impressed with that.
Yeah, I also like the branding of the Savor Score. algorithm. It's a nice touch. I think that oftentimes simplicity is actually very difficult to achieve. It's very hard sometimes. It's very easy to make something that has tons of buttons and let the user do all the work. I think this is great. I haven't had lunch either, and so this is a very timely. This is my angry mode, by the way. So you guys, don't stop this presentation. Yeah.
That's great. And again, it's very impressive, the remote students, the work that they did. I'm really proud of the program.
Yeah, exactly. Yeah. Great job, instructors and fellows and students.